Hey, what's going on, everyone? Adam the Tutor here, coming back at you with another Mclauren series problem. And this one, little bit more involved than the last one, but it's nothing too bad here. So again, let's just write our formula for the Mclauren series expansion. And this time, I'm only gonna do the first four terms. In the last one, I did more than four. That's okay though. Then x to the n over n factorial. Okay, so now we do n equals 0, and didn't mean to do f of x there. That should be a 0. Let me just correct that right there. Okay, and 0. Okay, so we'll have f of 0, and let me just go ahead and write my f of x as well. That'll be 1 plus minus x squared to the negative 1. So f of 0 is just going to be 1. And then we'll have x to the 0, which is also 1. And then we'll also have 0 factorial, which is also 1. So the first term is just 1. Okay, not too bad. And now we need n equals 1. So let me go ahead. I'll just do my derivatives over here since we're only doing the first four terms. So we'll have plenty of room here. First derivative. Okay? So the first derivative, we'll have negative 1 will come down, and we'll have 1 plus minus x squared, negative 2. But then we need to take the derivative with respect to the inside. So that's going to be plus minus 2x, right? So we know that when we evaluate this at 0, well, the bottom here is going to give us a 1, but the top here is going to give us a 0. So the first derivative evaluated as 0 is just 0, right? And of course, we'll have our x to the first, which is just x, and we'll have 1 factorial, which is just 1. But, this is 0, so our n equals 1 term will be 0. Okay? Now how about n equals 2? Okay, so again, we need to take the derivative. So f2 of x. Well, now we're going to have to use the product rule, right? So we'll take the derivative of the first, which will be 2, 1 plus minus x squared, negative 3, and then times plus minus 2x. But we'll also have this other factor that stays with it, right? Okay. And then we're going to have plus this guy. So actually I should probably put minus there. So minus 1 plus x squared to the negative 2 times the derivative of this guy, which would just be plus minus 2, right? So when we evaluate this guy at 0, well, this first term, we're going to get a 1 in the denominator, and 1 to the negative 3 is still 1. But notice we're going to get a positive 4x squared here, but when we plug in 0, this whole first term is 0. Right? Now let's go to the second term. Well, we'll have a 1 to the negative 2, so that's just 1. We'll have a negative 1 times positive negative 2, so that's going to flip the positive negative, and we're going to get a minus plus 2, right? And of course, we'll have an x squared here, and a 2 factorial here, which is just 2, right? So this guy, well, we'll have a negative positive 2 in the numerator, 2 in the denominator, so those cancel, so we'll have a negative positive x squared. Okay, and then now for our final term, we will get, so let me put this guy here. I'm only going to do the first four terms, because that's what the problem says, right? So we'll have the third derivative. Also, these derivatives are going to get kind of lengthy here. So, okay. Alright. So now we'll need to do two sets of product rule, right? So the derivative of the first guy will be negative 6, 1 plus minus x squared, x to the negative 4, and then we'll have times plus minus 2x, and then we'll still have this guy, which is going to be 4x squared, right? And then we're going to have minus 2, 1 plus minus x squared, x to the negative 3, and then we're going to have, see, so then that would be, okay, so that would be 8x, right? Yeah, so 8x. Okay. So now that takes care of this first term, so now the second term. So then what we're going to have, and let me go ahead and put this in brackets here. So we know that that's the first term. So then we're going to have plus, okay, well the derivative of the first, I'm going to get a negative 1, negative 2, so that's going to be a positive 2. 1 plus minus x squared to the negative 3 plus minus 2x, and then, well, just times plus minus 2. Okay, so now we need to plug in for x is equal to 0. Well, this guy is going to give us a 1. This guy is going to give us a 0. This guy is going to give us a 1. This guy is going to give us a 0. This guy is going to give us a 1. And this guy is going to give us a 0. So here we have 0. That'll be x cubed. 3 factorial will be 6. So basically, this will be 0. So with this, the first 4 terms, or, well, you know, I'm not going to write the zeros, but basically this will be the result when we plug in the first 4 terms, right? And again, you know, I'll mention, hey, you know, if x is much less than 1, then f of x, and this should really be an approximately equal to. Let me do that right quick. So f of x, and I don't know why I wrote an x there, but there we go. So f of x will roughly be 1 if x is really small. So that is going to do it for this video. Again, I went kind of quick there, but you know, it's really just taking derivatives and plugging in, evaluating those derivatives at x is equal to 0. So that's going to do it for this video. If you have any questions, comments, or concerns, leave them in the comments section below. And I would like to thank you for watching, and I will see you in the next video.